Hello everyone, welcome back to my YouTube channel. Myself Kirtana HR, currently pursuing in third semester in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bengaluru. Today's subject Operating System and the code BCS 303. And today's presentation is on types of system calls. Introduction to system calls. System calls provide an interface between a running program and the operating system. They enable user-level processes to request services from the kernel. Understanding system calls is essential for grasping how operating systems function. Now let us see definition of system calls. A system call is a programmed request for a service from the operating system. It acts as a bridge between user applications and the kernel. System calls are essential for executing operations that require higher privileges. Now let's have a look on types of system calls overview. System calls can be broadly categorized into several types based on their functionality. The main categories include process control, file management, device management. Each type serves different processes and has distinct operational characteristics. Process control system calls. Process control system calls manage processes in the operating system. Examples include fork and wait, which create, execute, and terminate processes. These calls allow processes to be managed efficiently and effectively. File management system calls. File management system calls handle the creation, deletion, and manipulation of files. Common calls include open, close, read, and write, which manage file operations. This ensures that applications can interact with the file system securely and reliably. Device management system calls. Device management system calls interact with hardware devices. They include calls like read or write, which control device operations. These calls ensure proper communication and functionality between software and hardware. Information maintenance system calls. Information maintenance system calls manage system related data. They include calls such as getPID and alarm, which retrieve or set process and system information. These calls provide mechanisms to monitor and maintain system performance. Communication system calls. Communication system calls facilitate data exchange between processes. They include calls like pipe, message-get, and which enable inter-process communication. These calls are crucial for multi-processes applications requiring synchronization. Socket program system calls. Socket system calls are used for network communications between devices. Calls such as socket, bind, listen, and accept establish and manage connections. They enable applications to communicate over a network using protocols like TCP or IP. Example of process control call. The fork system call creates a new process by duplicating the calling process. After a fork, both the parent and child processes can execute independently. This is fundamental for multitasking in operating systems. Example of file management call. The open system call is used to open a file and returns a file descriptor. The file descriptor is used for subsequent operations like reading or writing. This call is crucial for file access in applications. Example of device management call. The call manipulates the underlying device parameters of special files. It provides a way to send control commands to devices. This call is vital for customizing device operation behind standard input or the output. Example of information maintenance call. The getPit system call retrieves the process ID of the calling process. This information can be used for debugging or process management. It is essential for identifying and controlling processes within the system. Example of communication call. The pipe system call creates a unidirectional data channel for inter-process communication. It allows one process to send data to another seamlessly. This is a functional feature for building complex applications. Example of socket call. The socket system call creates a new socket for network communication. It allows applications to send and receive data over networks. This call is foundational for developing networked applications. Security considerations. System calls must be designed with security in mind to prevent unauthorized accesses. Proper validation and error handling are essential to safeguard against vulnerabilities. Understanding the security implications of system calls helps maintain system integrity. Performance implications. The frequency and type of system calls can significantly impact system performance. Overhead from user kernel mode transition can slow down applications execution. Efficient system call design can enhance overall system responsiveness. Conclusion. System calls are essential for enabling communication between applications and the operating system. Understanding the different types of system calls enhance our ability to develop efficient software. Knowledge of system calls is crucial for system performing and operating system design. Thank you everyone for watching my video.